Hello everybody. Well, one of the most common things I find that people struggle with is transposition of formula. And in this video we're going to start off with just a simple three terms, and a subsequent video will look at other things. Now, where confusion comes in, first of all, I find, is that people are often saying, why on earth are we using letters, such as an A, in the actual mathematical formula? Well, there's quite a simple reason for that. Sometimes you have numbers such as 2, 3, 5, whatever it is, 160, it doesn't matter what the number is. Those numbers are definite numbers, but sometimes we have numbers that change. So for example, if you were cooking a sausage roll, a single sausage roll, you would put a certain amount of flour in, let's say it's 10 grams. And if you were making 100 sausage rolls, then it would be 100 times that 10 grams that you would need of flour in order to make the sausage roll. So the formula for that would have a letter or a character of some description, it can be absolutely anything, to represent the amount of flour. So that you could put in, I want 100 of them, and the formula would churn out with the right amounts. Okay, so that's what we use it for. We use letters or characters or symbols to replace actual numbers where they're going to change. And quite often the most common one you probably see used is just the simple letter X, and you often hear that X is an undefined number. Well, actually, every character or symbol that isn't a number is an undefined number when it comes to a formula. So there are certain numbers that are used in mathematics and science and technology and engineering and all those other subjects that we have characters that we use for them consistently. So I'm an electronic engineer. I would always use I to represent current, for example. A mathematician would tell you that there are certain characters such as E and pi, which are definite numbers, and we know what they are. Okay, but you don't need to worry about that. For the purpose of transposition, each letter or character is just a representation of an unknown quantity. Okay, so let's have a look at some three-term formulas, and I'm just going to use the characters pretty consistently of A, B, and C. Okay, so we could say in three terms A plus B is equal to C. We could say A minus B is equal to C. We might say that A times B is equal to C. But quite often, when it is multiplied together, most people in maths do not put this symbol in. They do not put the times in, so they would just write it as A, B equals C. And that's why you sometimes see characters and letters put together. And then we have A divided by B equals C. And there is another way of writing that too. A divided by B equals C. Now personally, I prefer to write it in that format, and I write it in that format as you're going to see in a second because it makes life easier to see what's moving and what's going on within the actual formula. So let's get ourselves a new sheet and let's have a look at things. Now when it comes to transposing formula, we usually use a set of simple rules, and if you use those set of simple rules consistently, then you should be able to do things. Now, first rule, no matter how big the formula, I need to work out what it is that I want. So in this particular instance, I have A plus B equals C. Well, what if I know what C is and I know what A is? Then it's B that I need to find. So I need to get B all on its own. Now, first things first, B has a plus, and you always put the symbol and the letter together in your mind. Now A and C do not have a symbol. Well, if they are a minus, then you have to put the minus in, and if they are not a minus, you just leave it as it is. So that means that actually we have plus A plus B equals plus C, but we never write these in. Okay, we assume that everybody knows. So the first thing I'm going to do, just to help myself and make sure that I'm where I want to be, is I'm going to just write some numbers. And what I'm going to do is pick low numbers below 10, so it's nice and easy, and I'm going to say write 2 and 5 above there. So in my starting formula, 2 plus 5 equals 7. So that's a nice easy start. Now I want to transpose it. And if I can get the pen to work, there we go. So I want to transpose this formula to get B all on its own. So the first rule comes into play now, equal and opposite. Now if you imagine a set of simple scales with a little hanging basket and a little hanging basket, this equation is balanced, and this equals is like the pivot of a scale. So whatever is on one side, so 2 plus 5, so 7, is on the other, 7. And when we move the formula around, we have to maintain that balance. And there's a simple, easy trick to doing it. So in this case, I'm looking for the equal and opposite. So what is equal and opposite to plus? Well, the answer to that is minus. So if I want to move A and leave B on its own, then all I have to do is rewrite my formula as A, which is a plus A, minus A. Minus is the equal and opposite. So A is equal, minus is opposite, plus B equals C. Now, I have put a minus A on this side, so there's more on this side of my scale than there is on this side. So it's going to be tilting this way, or it's going to be tilting that way because I'm taking things away. So I need to make that even. So as I've added the minus A, the equal and opposite, I take away a minus A on this side as well. Now, any number, 2 in this example, minus itself is 0. So I can cross out those two characters. We don't write a plus, so B equals C minus A. Now I'm just going to get my red pen back again, and let's have a look if that is true. So B is 5 equals, and C is 7 minus 2. So C is 7. I should have written a 7 there, sorry, not a C. So 5 equals 7 minus 2. Is that true? So I now know that I have transposed that formula to find what B is equal to, quite simply because I've put in some very basic numbers just so I can check it. And you tend to find you understand it easier. So let's have a look at the same formula again, but this time I'm going to find B. A, sorry. So A plus B equals C. And I'm going to pick a completely different set of numbers. So I'm going to say 3 plus 4 equals 7 again. Okay? So this time I'm going to transpose my formula, and this time I'm going to find A. Now remember, A is a plus, and that's okay. We don't need to. B is definitely a plus because it says so. So I'm going to do the equal and opposite. And what I'm going to do is A plus B minus B equal opposite equals C minus B. Okay, so again, B minus B is nothing, so that all disappears. And then we come up to rewriting that formula, so I have A equals C minus B. So we can check that now using the same numbers we did above. So 3 equals 7 minus 4. And is that correct? Well, 7 minus 4 is 3, so my scale is balanced and I'm correct. So that's a simple plus. We can do exactly the same with using minuses, and the equal opposite of a minus is a plus. So this time A minus B equals C. and I'm going to get my red pen again. So let's go 6 minus 2 equals 4. So 6 minus 2 equals 4. This time I'm going to find out what minus b is. Okay, so this time I'm going to transpose it by adding a minus b. The equal and opposite is plus b equals c plus b. Now a minus number plus a positive number that are both equal, so therefore opposites, disappears. So we can cross that out. So my formula should say that a equals c plus b. And if I get my red pen again, we can check that. And we can say that 6 equals 4 plus 2. And you can see that that's correct. Now, in reality, on an actual formula, these numbers could be anything. They could be 176,000,03825, 246,000, etc. It doesn't matter what they are, and it doesn't matter what they represent. We are putting in the red numbers as simple numbers under 10 just to check. And all we have to do is fill in one side of the formula with those numbers and work it out to find out what the other side is equal to. So now we can do the same with times and divide. And then perhaps we'll have a look at some quick tricks. So, if I now say A times B equals C, and I'm going to get my red pen again, and I'm going to put in some numbers to check myself. 2 times 4 equals 8. Nice simple numbers again. Okay, so this time I need to transpose it. But I have to do the equal and opposite of a times now, not the equal and opposite of an add or a subtract. So what's the equal and opposite of a times? A divide. Okay, so this time it's A times B equals C. But I'm now going to divide everything by B and divide this side by B. Well, B, if B is 10, or 4 in this case, doesn't matter what the number is, and you divide it by itself, it goes back to itself. So if we had a look at this, 2 times 4 is 8, divided by 4 is back to 2. So B divided by B is just 1. So A times 1 is just A. So all we need to do is remember that we have two identicals and cross them out. So let's rewrite that formula. What we have left now is A equals C divided by B. Okay, so getting the red pen, let's check those numbers. 2 equals 8 divided by 4. And hopefully you know that's correct. Okay, so I'm using simple numbers and simple techniques of equal and opposite to move everything. But there is another quick little technique here. And if I rewrite it on this side, A times B equals C. Anything that I want to move that is a times on one side will move to the other and become a divide. And anything that's a divide on one side will move to the other and become a times. And that's why I prefer to write things like this, because it's easier to see. So I can simply, using that rule, move my B by knowing that it's a times on that side, so it must divide everything on that side. Okay, so I don't need necessarily to go through this because I know that rule. However, going through this and your checks will actually get you there safely and make sure that it's right. The checks are more important than perhaps you might know. So this time A divided by B equals C. Now here I have a problem. If I want to find b, it is on the bottom half of the equation. So if I took a over, it would be 1 divided by b. Because don't forget, I'd be dividing both sides by a, and a divided by a would be 1. So it'd be 1 over b. So I don't want to find 1 over b equals c over a. I don't want to find that at all. And there's two ways I can deal with that. Either I don't do that in the first place, or I know that I can flip this upside down. So b would equal a over c. But don't take my word for it. Let's actually do it. So let's put some numbers in over here. So I'm going to put 10 divided by 5 equals 2. Okay. So I'm going to look at these numbers a little bit differently, and I'm going to write that out again. A over b equals c. And I'm going to divide both sides by a, like we said. Dividing both sides by a divided by a becomes 1, so that's 1 over b. And c divided by a is c over a. Now if I do this, b is 5, so 1 divided by 5. Ooh, wrong colour pen, sorry. Let's redo that. So 1 divided by 5 is the same as 2 divided by 10. So it's correct. It's correct, but I want b. I don't want 1 over b. So if I rewrite it over here, having flipped it upside down, it becomes b equals a over c. So now let's check my numbers. So I'm going to put the same numbers in before. So b was 5, a is 10, and c is 2. So 10 divided by 2 is equal to 5. So that works. Something else that we can show you as well, that's nice and easy, is a over b equals c. Now that's the same formula as before, but I'm going to use a technique I mentioned before. I can swap anything on the bottom for anything on the top, on the other side, because that will become a times and that will become a divide. So I can do this in quicker steps. And let's just do our numbers again. So 10, 5 and 2. So 10 divided by 5 equals 2. If I directly just swap those two over, so b goes up here and c goes down here, just to prove it, we have a over c equals b. Okay, so putting in my numbers now, numbers I made up earlier, 10 divided by 5 equals 2. Okay, so what we always do, always, until you are very, very versed in transposition, is you always move one thing at a time. You can use the little quick swap cheat, but use one thing at a time. Put in numbers that make sense and are nice and easy, so we try and be numbers of 10 or less. Sometimes you have to go a little higher on the answers because of the numbers you've selected here. It doesn't matter. And then we try transposing our formula and we actually put them together. So what I'm going to do now is I'm just going to look at that in a 4-term formula just to show you why we would do those. So a times b all divided by c equals d. Now if I try to rearrange that just to find a, I can do that in my head because I've had lots of practice. Can you? Probably not, or you wouldn't be watching the video. So let's do this. 2 times 3 is 6, divided by 6 is 1. Okay, so that is my formula there. And I said I want to find a on its own, which means I've got to take everything over there. So I could do both in my head very quickly, or I could be very, very safe and make sure that I do it correctly and move one at a time. So This line here acts on both A and B. So both A and B are divided by C. And because they're both divided by C, I'm going to move C first. So I always move the thing that is acting on everything else, or last thing that the formula says to do. And we'll come on to that in a little bit when we do higher level formulas. So A, B over C times C equals D times C. Okay, so C divided by C, or any number divided by C and times by C, will just be that number. So those two there will cross out. Okay, so moving up here, A times B equals D times C. But I'm going to write that correctly. AB equals DC. Okay, now I want to move the B. So I'm going to do that in my second step, and I'm going to divide both sides by B. Okay, B divided by B is just 1, so it cancels out and disappears. So my final formula should be A equals DC divided by B. And if I go over here and I bring in my numbers, so A was 2, B was 3, D was 1, and C is 6. So 1 times 6 is just 6. 6 divided by 3 is 2. So I know I've transposed the formula correctly. And hopefully that will show you the most basic form of transposition with just 3 term formulas, and hopefully help. Do feel free to watch the video again, and can I suggest that for each one that we went through, write down the start formula before I transposed it, try it yourself, try and get the correct answer, the same answer as I'm getting, and then watch the video to make sure you did it correct. Mathematics is like anything else. You cannot learn it by looking at somebody else doing it. You cannot learn it by just doing it once. You have to repeat and repeat and repeat for the technique to become part of your long-term memory.